Hey, good morning. In this video, we're going to go on to looking at formulas. The last 2 days, we looked at how to take a chemical formula for a compound. So, knowing the compound's formula and name it for level 1, level 2, level 3. In this video, we're going to look at how to do the opposite. If we're given a name for a level 1, 2, or 3 compound, how do we write its formula? And luckily, we're going to do the same set of steps for level 1, level 2, and level 3 compounds. We're going to talk about all of them together in the same time. All right, so I have my periodic table here and, excuse me, my polyatomic ion sheet because I'm going to need both. And we're going to write ionic formulas. So, what are the steps to write an ionic formula? So let's use an example. Let's say that we were given copper 2 sulfate. First step is to find the ions on the periodic table or the polyatomic ion sheet and write them down. So I'm going to find copper on the periodic table right here, Cu, and I'm going to find sulfate on the polyatomic ion sheet, SO4. Number 2, I'm to write the charges next to each ion. So we know from the name copper-2 that copper is a +2 since our metals are always going to be the positive ones. And we can go back to our polyatomic ion sheet, find sulfate, and see that it's a -2. There we go. Now 3. I need to make sure the charges on the ions cancel out, equals 0. If not, if they don't, I need to add atoms of one or both using subscripts. And that little number is a subscript. So in this example, I have copper, which is +2, and sulfate, which is -2. This already balances out, so I don't need to add anything. I don't need to add anything at all because they already balance out. The last thing I'm going to do is write final formula without any of the charges on it. So in this example, we'd have CuSO4. Done. Copper sulfate, copper 2 sulfate. All right. So let's try like 3 examples to show you some other ones. All right, this one is magnesium sulfate. I go up, find magnesium, Mg. Then sulfate is the same as before, SO4. Write them down. Second step, remember, write the charges next to each one. We know from the last example that sulfate is -2. What about magnesium? Well, remember in the periodic table there's that trend of charges. +1 for this column, +2 for this column, +3, plus or -4 here, -3, -2, -1, 0. So magnesium is right here in the +1, +2 column. Three, we need to make sure that these balance out, and if not, add atoms of one or both ions. So +2, -2, that already balances out. So now we're just writing our final formula without the charges, MgSO4. Let's try one where they don't balance out. Calcium citrate. Find calcium, Ca, find citrate, C6H5O7. Write their charges next to each. So again, calcium, like magnesium, is in the second row or column, so it's +2. Then looking at the polyatomic ion sheet, citrate, it's -3. Okay, so we need to think, these aren't balanced. +2 and -3, there's more minuses than pluses. What could we do to make sure they're balanced if we add more atoms of either one? Well, let's see. Let's add another atom of calcium. So Ca2, C6H5O7. So this would now be +4 because we have two of these. Two in each are +2, so +4, -3. Still not balanced, so we need to add another citrate. Ca2 +4. And when we add another polyatomic ion, we need to put the whole thing in parentheses and then add the little subscript after the parentheses. -6, because if there's two and each are +3, -6. All right, now still not balanced. We need to go back and add another calcium, Ca3. And if each Ca is +2, +2, +4, +6. That's a C, weird. Now they're balanced. Look, +6, -6. So now I just need to write what I just have here as my final formula, but without any of the charges. So my final formula are going to be Ca3, then keep my parentheses, C6H5O7, 2, calcium citrate. Let's do one more. Okay, one more. Beryllium oxide. Nah, let's not do that one. That one is just super easy again. They balance out. Ammonium nitrate. That's a good one. So look, first step is writing down the symbols, but this has two polyatomic ions. So we'll find both of them on the polyatomic ion sheet. Ammonium is NH4, and then nitrate, NO3. Or, hey, let's change this because, like I said, I don't want these to keep balancing out. I want to show you some different ones. Ammonium, all right, NH4. Now we'll change it to sulfate. Sulfate is SO4. Just making a change there so it doesn't keep balancing out. Then I'm going to look at the charges for each. NH4 is +1, ammonium is +1, and sulfate is -2. Now we need to see that they balance out. +1, -2. They don't. So there is more negative than positive. So I need to add another positive polyatomic ion. So I'm going to put NH4 in parentheses and then add another NH4, 2. So that becomes 2 of them, and each one is +1, so that's +2. SO4 is a -2. Now these balance out, so I can write my final formula without the charges, NH4, little 2, SO4, ammonium sulfate, and that's it. All right, that's all that we have for this video today. We'll talk more about this tomorrow, but I hope you have a good day.